So I went on a river cruise in France with my wife a couple weeks ago. And so we saw these Roman ruins and stuff like that. Mm-hmm. But the best part of the trip was so they sell this all-you-can-drink package on the ship. And it's usually 300 euros and for the whole cabin. But my wife doesn't drink at all. And I'm in wine country. I'm going to drink lots of wine, right? So I talked the maitre d' guy into doing it for half price, 150 euros. My final bar bill was 1,604 euros for 150. It was a good week. And it wasn't like I was sitting there like, just shooting back shots or anything. I was like with lunch, I was having like an $80 bottle of wine. Like, oh yeah, it was because it didn't matter if you got all you can just like you just go down the list like, it's all written in like weird, like one thing I learned about French wines is like the names of them is all there. You don't know because there's like the vineyard, the part of the country. There's all these Frenchy words that you can't pronounce next to each other before you even get to the year. So you don't know what you're getting. I think if you were from that part I think it's really easy to read. It's very descriptive if you're from that part of the world, but that was the highlight of the trip. So that was pretty. Oh, and the food. The food was really good.
What about Mr. Gonzalez?
Oh, Mr. Gonzalez, he was a hit. It was it was up on his page, right? I think Mr. Gonzalez's page had pictures of him up. He sat for 45 minutes up on the piano. In the lounge one night when they were playing all this piano music and stuff. So he was, I guess, helping sing or something. It was a thing. All right. Anybody else have any fun trips they did over the summer?
Good question. Did the wines actually taste good or are they just bad?
No, they tasted good, but after the first couple glasses, wine's wine.
Fair enough.
Oh, I did do something kind of crazy. We were at this Roman aqueduct in Avignon. I think that's the name of the place it was near Avignon. And we were there with my pastor and his wife, and my wife was there. And they wanted to hike up to like the top of this thing to get some picture of the aqueduct from a different angle. And I guess I didn't see the point of hiking for 45 minutes to take a picture of something you're standing next to.
Perspective.
Well, I got even a better perspective. So I decided instead of going there, I went down because like this aqueduct is by this like unnamed river.
Okay. That
there were people kayaking in. Nobody was swimming in it. I don't know if I should have been concerned about that. But they were kayaking in this thing. So I figured, I'm going to go get in the water. I didn't have a suit or anything, just my clothes I was getting ready to get back on the bus with, right? So, they were going to spend an hour hiking up this mountain or whatever. So I go down this thing. It wasn't even like I had to go down like hillside to get down there. And I just went in the water, took video of the aqueduct from the middle of the river. It's better perspective, isn't it?
Different perspective.
Yeah, a better perspective. Definitely better. So I noticed you didn't have the obvious follow-up questions. When in France. Okay.
France stays in France.
Let's see. Oh yeah, Bible homework already. All right.
I noticed that. It's 32.
So we can read this, right? Trust me, this TV is going to be way better for code and stuff. Okay, so this is the second programming class. Theory and practice 1, whatever, blah, blah, blah. So everybody in here should have already had CSC200 or something equivalent-ish or blah, blah, something. All right, so that means most of you have had Python or something like that. Unimportant, right? Because programming is programming. So now you have a entry-level skill set in programming, and now we're going to get a more advanced skill set in programming. So you can read through all this jazz, whatever. I'm going to change this actually. So homework assignments are 45% of your grade. That's going to change to 60% of your grade. Because quizzes are 15% of your grade historically, but since some semesters I give more or less quizzes than others. Let's say I give 2 quizzes and you miss one of them. Now you got a 50% average for 15% of your grade. So what I'm going to do is I'll just wrap quizzes and homework into one grade. So one missed something isn't that big of a deal. All right. So this will be 60% for both of these combined. That makes sense? It benefits you, trust me. All right. So, and I'll get it updated on there. In fact, I thought I had updated it. Maybe I only did it for 325, but whatever. The other stuff's the same. Midterm, final, 20% each. I have my policy where if you do better on the final exam than you do on the midterm, I'll replace your midterm exam score with whatever you get on the final. So if things just haven't clicked yet, or if you just have a bad day on the midterm, you can get a complete do-over with the final, but don't suck on both. And it doesn't go the other direction. You can't get like 100 on the midterm and then just skip the final. So it's a cumulative type thing. If you've shown, my job is by the end of the semester to give you a grade based on how well you've mastered the material, and one day shouldn't screw your grade over. But maybe 2 or 3 or 4 days maybe could, I guess. It's the game, right? Normal 90, 80, 70, 60 thing. Top and bottom 2% is the pluses and minuses. So like an 88 is a B plus, an 81.9 is a B minus. That thing, somewhere in there. Usually, if you're on the cusp and you showed good effort in class and all that jazz, then I'll probably give you the bump. If you're on the cusp and you blew off class, I probably won't. So whatever. Attendance, I'm supposed to take attendance every single class. I don't. So you're adults. If you want to be here, be here. If not, that's fine. I mean, you might miss a quiz. I won't let you redo the quiz. You're responsible for anything we do in class. So if you have something better to do, then you're just risking missing a quiz or something. One thing that you could almost bank on is I tend to give quizzes when there's lots of people missing from class. So times when that hits computer science majors is major releases of new video games. I think I'm kidding. When you have half the class missing the morning after some game comes out, probably missed a quiz. So whatever. Also, I tend to give quizzes this came with a little carrying case. So cute. It's for my fan. All right, so I tend to give quizzes like the day right before break or something like that, like the last day of class before you're supposed to go on break, because people tend to skip those days. If you have a significant reason why you can't be here that day, for instance, I will save $600 on a flight if I leave the day before or something, come and talk to me. We'll work it out. This is like really high quality. Feel that?
Yeah, that looks pretty good. Can you lift it or whatever it's called? Like the I don't want to. Yeah.
That thing where don't some people use those for weapons and stuff?
I think so.
Is that like an actual thing, or is that just?
Well, I don't know. Does anybody know? Is the fan weapon an actual weapon, or is that just a movie thing?
It's actual. To flip it out.
That'd be like a really strong axe to use as a weapon.
Just need to be hard.
You need the other.
Yep. It's just knives. It's just knives.
All right. Questions about syllabus and the class and that kind of jazz? Makes sense? If you've had my class before, it's the same thing as usual. Okie dokie. textbook, similar to last time, there is a required text. So you go to zybooks.com and you have to put in this dude here. And I'll show you the book. And you will have assignments from the book. It is a good one. All right, so this is a Java textbook that will show you, give you practice doing things, converting from Python to Java. It is a good book. If it was up to me, I'd charge less for it, but it is what it is. All right, so what is it, like $60 or something?
Something like that.
One possibility, since you won't have stuff from the book that is like officially graded, you know, like you won't have to submit, like I won't go and check the book for stuff. And I'm not necessarily recommending this, but I'll go ahead and announce this the very first day. Just like the 200 class, many of you are going to find the homework assignments and stuff in here hard. Right? I mean, it's the programming is a tough thing. And like I explained in 200, it's like a sport. And right now we're still practicing. And some of you have already caught on. Some of you haven't caught on as quickly. And that's okay. That's where, you know, it takes different speeds. So usually there's 2 or 3 different study groups that start up in here. I know Blaine and these guys usually do some kind of groupie thing, right? And then there's like one other group that happened last semester, but I would strongly encourage you to get on Slack. Is everybody in here on our Slack channel already? Anybody not know what I'm talking about with Slack? Okay, good. So I would encourage you to maybe go on to 250, the channel on there. And if any of you are interested in starting a study group, maybe put a note in there. I'd encourage you to get with 3 or 4 or 5 other people and do your homework together, that kind of stuff. The stronger people in the group will learn more by teaching some of the weaker folks. The weaker folks will learn more by hearing the same concepts from a different perspective than just hearing it from my perspective. When I go to grade your homework, I am not looking for cheating. Okay? Collaborate. I'm fine with that. I will find out on the exams. All right. Your whole goal is to learn the material and my way of testing how well you've learned the stuff is going to be through quizzes and through the exams. Okay. So if you turn in the identical program as whoever's leading your study group, I don't care, but just make sure you've learned from doing that with that person. Make sense? Okay. So, and I promise you, when we come to midterm or even close to midterm, somebody's going to come to me or several of you are going to come to me and say, oh, I'm not doing well in here. What can I do? Get into the study groups at the beginning. Work on your homework with other folks. Find people who have a similar schedule to you or who get together and work on the assignments and take advantage of that. Trust me, it will benefit you. Okay, so if you are interested in study group stuff, maybe go ahead and in the 250 space, just post, I'm interested in study groups, and then whoever is going to kind of form study groups can maybe reach out and you guys meet together or something like that. All right. Have I really driven that point home that that's an important aspect? You will do better in the class if you participate in that type of stuff. All right. And also keep in mind, like I said before, you are actually benefiting those students who maybe have caught on more quickly, because when they have to teach it to you, they're going to become even better at it themselves. All right. So you're not just, taking advantage of them. All right. So if you're in that group of folks who have already caught on or had this stuff before, things like that, take advantage of running a study group because it will benefit you as well. Okay. All right, so textbooky thingy. Sometimes I will reference the textbook directly, but usually what I'll do and what I was getting at before is I'm not going to give you an assignment like do this from the textbook and submit a screenshot or something like that. I might say there will be a quiz next class over the stuff from chapter 2 of the textbook, that kind of thing. So if you guys wanted to go in as a group and maybe one person from the group gets the textbook and then you guys get together and study and things like that, I don't care. Whatever makes you guys happy. I'd encourage everybody to get it themselves. I don't get any kickback, so it doesn't really make any difference to me. But do whatever makes you happy. But I will be giving you reading assignments and stuff from the textbook, but you won't have to submit something from the textbook that is, supposedly your own work. It'll be read chapter 2. There might be a quiz on it next class. Got it?
Got it.
All right, so play whatever game you want to play. Okie dokie. But in any case, if you click on the required online text thingy, it'll tell you to go to zybooks.com. You have to paste in this little code thing here, and then it'll say, give me your money. And then you'll have that book for, I don't know, to the end of December or something. I think it tells you the whatever, but you'll have it. There are other Java texts out there that if you're looking for, effectively a Java reference, which is what this book mostly is. I do think the zybooks is a good tool. So I think it's worth the money. So I don't want to undersell that. But another book that's pretty good that you might be able to find an older version of pretty cheaply is the book by Deitel, D-E-I-T-L. It doesn't matter how old of a version you get. Java hasn't substantially changed in terms of the stuff we're going to be doing. So if you're looking for a cheap Java reference, you might even be able to, I don't know if they've open sourced some of their older ones, but you might be able to find PDFs of some of the older ones. I'm officially not telling you to steal a book, but it's possible that from version 6 of Java, they don't sell it anymore and they've open sourced it. I don't know. But in any case, you don't have to get the newest, latest, greatest of that. Java has not substantially changed. Those are reasonable books. Lots of online resources for Java. So we all on the same page? All right. So as always, if you have my classes before, I give weekly Bible homework assignments. This benefits you in multiple ways. First of all, here at Concordia, we are a Lutheran university, and we're supposed to incorporate a Christian worldview into the classroom. So every single week, I will give you a chapter from the Bible to read. You then have to write 1 or 2 paragraphs reflecting on how that relates to your vocation. Okay, there are going to be lots and lots and lots and lots and lots of reasonable answers. Right? Some chapters might be easier for you to connect than others. The real motivation here is I'm forcing you to read the Bible. Okay? And then comment on it. So this should not take you very, very long. This should be free homework points, effectively. There isn't a very good excuse for not doing the Bible homework. I try to put it up as early in the week as possible, and it's due by midnight on Sunday. I think technically 11:59 p.m. on Sunday is what the cutoff is. All right. So every semester it baffles me the number of people that just don't do it. This is 10 minutes of your life for free homework grade that will offset a bad quiz or something like that. Okay. Do it. All right. These will be up every single week. If you are in more than one of my classes, it's the same assignment each week. So you can double dip. You can just turn in the same solution to both classes. All right. Questions about that? First homework's already up. It's due by midnight on Sunday. Who?
September 2nd.
Yeah, that's Sunday, isn't it? I just click on the calendar for Sunday. I did that. Yeah, there's a pretty low chance. I'm not saying I didn't screw it up, but there's a low chance I screwed it up. All right. Questions, comments, concerns, bribes. Okay, so in this class, we're going to be doing a couple of different things. We're all beginner/intermediate programming skill set people now. We are going to be converting languages to Java. So I'm going to actually do this. Start a new. And I'll put a link up to this presentation. I'm going to do an experiment here and try to do all my classes on this Windows laptop this semester, so I don't have to schlep my Mac in. But if that doesn't work out, I'll switch to the Mac. It's from your perspective, it's the same. We're using the same tools, whether it's Mac or Windows. But I teach the game programming class on Tuesday, Thursday mornings, CSC250. Which, by the way, if we've only had one class. If you are interested, if you have a extra spot in your schedule, CSC250 Game Programming 1 is a pretty cool course if you're interested in the programming stuff. We're using a tool in there called Unity, and the programming stuff you do in there is easier than the programming stuff we do in here. It's a different kind of programming. You're writing less algorithm stuff and more of, let's make these three things happen in a certain order. So if that's something that's interesting to you and you have 15 hours or less, I'd encourage you to maybe take that class. It'll count as an upper division computer science elective. And I think it'll help round out your programming background type stuff. It is at 8:05 a.m. Tuesday and Thursday, so it does require you to get up. But I think it'll be a pretty fun class. Several of the folks in here did some of that stuff over the summer and things like that, and fun, good stuff.
Real fun.
Yeah, so I'd highly encourage it if you have the open credit hours, because you're already paying for 18 credits with your tuition. So I don't think it's going to be a major additional drain on your time. This class will be more time consuming than that class. Got it? All right, and that's CSC250 that has a prerequisite of 200. All right, so this is CSC250, and if you want more information about that, just come up to me right after class and I can talk. Okay, so just reviewing a couple of things here from 250. We'll just repeat ourselves a little bit. Remind me, how do humans solve problems?
Repetition.
All right, we'll go out of order here. Okay. Next. I think you heard you whisper something. You want your weapon? Okay.
It's okay.
What'd you say?
Ask questions.
Ask questions. Some of you literally just took 200 over the summer. This should be pretty fresh in your mind. What's the way human beings solve problems?
You just write memory.
Memory, yeah. All right, so we use our memory, we ask a lot of questions, and we do repetition. Okay? 100% of programming languages, 100% of them have facilities for these three things. All right, let's see. Oh, is it going to let me? Can I copy this? Nailed it. All right. So I usually have called this slide, the mapping or something like that. So repetition is accomplished through loops and functions / methods. Asking questions is done through conditionals, usually if statements. And memory is variables. 100% of all programming languages have facilities for these three things. Okay, so again, just like I did in 200, I really try to teach programming from the perspective of programming is a skill set. It doesn't matter what language you're using. That's why we skip around languages so much. Okay, you had Python in 250. You'll have Java in here. The first part of the semester will be doing straight Java. The second part of the semester will be doing Java in terms of Android development. So we'll be writing Android apps in here. In software engineering, which you'll have next semester, you'll have 300 with me next semester, and you'll have software engineering with Dr. Locklear next semester. You'll be doing Visual Studio C# programming in software engineering, which is effectively Java. I mean, in fact, Microsoft, if you remember from 200, Microsoft tried to steal Java, got sued, came out with C#, which is their version of Java, basically the same language. Also in the Game Programming 1 class, the scripting language that we use in Unity is C#. So we get into the 450 class, we use C. We get into the 470 class, we use Scheme, which is a functional programming language. It's a superset of Lisp. So as you go through your years here in computer science at Concordia, you're going to be exposed to lots of programming languages that are all used in industry today. So these aren't made up languages. These are they're not made up languages for teaching. Back when I was in college a couple of months ago, there was a language called Pascal. Have you ever heard of Pascal? So Pascal was a language that was originally created just for teaching computer science. And then people ended up liking it. So then they Microsoft renamed that. Anybody know what they renamed the product that was Pascal based? Starts with a D. Delphi. Okay, Delphi. Then it was it was packaged into Visual Fox Pro. So so sometimes teaching languages turn into something more. But in any case, all the languages we deal with here are industry languages. If you go and look at the most popular languages for getting jobs today, I think we've posted some stuff. You could do a Google search on it. Number 1 is probably Java. Number 2 is probably Python or C#. Number 3 is the other one, C#. You probably are not going to find Swift high up in there. Swift is a functional language that you'd probably use in artificial intelligence type things. You'd probably see it referred to as Lisp, Lisp, but regardless, we use it. We create our own programming language using Scheme and then do our homework using the language we created. So that's a cool class. It's the hardest class we have here. You'll hate it, but it's it's a blast. I like it. You'll also have opportunities to do iOS programming. So we'll do Swift. That's probably a top 5 language somewhere, but probably either 4 or 5 on the list. But punchline is you're getting the industry leading languages here. So when you get out, you should have the skills that you'll need to get a job. Make sense? Mm-hmm. All right. So, and I really, really, really want to condition this idea in you that the language isn't important. I don't want to hear any of you as seniors saying, well, I like Java, but I can't stand C#. They're the same. Okay. They're the same language. So programming is programming. I want to instill that in you through your 4 years here, so that even if you get out and, for instance, a lot of our top students the last several years have gone and worked at Acuity up in Sheboygan. Mm-hmm. How many of you have ever been up to the Acuity offices? You've been up there? So Acuity insurance company sounds boring, right? I mean, it's like Google. They have rock climbing walls. They have a working Ferris wheel inside the office. I mean, it's literally like Google of the Midwest. It's a really cool place to work. But when you first go there, they don't assume anything. They assume that you have the ability to learn. They assume you have programming as a skill set. They put you through a 3-month training program where they train you how to do things their way. And they're really teaching you Java, and they're teaching you a language called COBOL, which is an old language. Not very many of them end up doing COBOL stuff, but they need to know enough about it to work with the COBOL folks. My wife has been a COBOL programmer for 20 years. So it is an old, and it was old when she started. So it was already old. Yeah, a lot of banks, insurance companies, things like that, you still use COBOL because they have a ton of software written in it. For business, it was designed for business applications, and it's cheaper to just continue to maintain it than it is to convert it. One of our former students, Nick Largen, works for Northwestern Mutual, and he works on the team that converts part of their COBOL stuff over to Java, but he also maintains their existing COBOL stuff. And you run into this issue where if you fast forward 10 years, you might say, okay, well, we would save money in the long run just to convert everything to Java now. But there's plenty of businesses that can afford $1 million in payroll this year to maintain COBOL. They can't afford the $25 million this year it'll take to upgrade everything to Java. So they'd rather just take the $1 million a year hit over and over and over and over again to maintain what's already there. And maybe just whenever the opportunity arises to switch something over, they will. So that's the world we live in. So you could actually, if you get into COBOL stuff, you can make yourself pretty lucrative money because there's a dying breed. And there's companies out there that will pay a lot of money for a COBOL developer because nobody wants to do it, and we don't teach it in school anymore.
Okay.
So, and it's not a hard language. Punchline is programming is the skill set. You can learn COBOL in a couple of weeks or something. Okay, so again, 100% of languages have this mapping. So if you can sit down with a brand new language you've never seen before and say, how do I define a variable? How do I write an if statement? How do I write a loop or a function? You can already solve a large classification of problems with that language right off the bat. Make sense? Now it's just a matter of kind of getting used to the new syntax. So like when you were writing Python, you kind of were used to putting little colons at the end of each line and then pressing enter, and then there was an indentation thingy, right? And I kind of indicated with the Python stuff that the indentation is actually really important because it forces you as a programmer to kind of format your code reasonably. Where when you learn a language like Java or C or C# first, which is I'm going to call it a curly brace and semicolon based language, you can become lazy and not indent your code because it doesn't force you to. All right, so I kind of like that about Python is it gets you into the habit of formatting your code. So I really encourage you to do that. And I'll point it out once we start writing some stuff. Okay, so this is the powerful tool here. If you know how to do these three things in a brand new language, you could already start programming in that language, and then you'll just bump into, as you're solving problems, the facilities built into that language for solving certain problems more easily. For instance, the language PHP, which came from C. If you remember this slide from 200, we had our little pictures. Is this my shapes? So we probably had, what, C at the top here? And then off C, I'll just, we had C++. Then we had Java. And then I probably drew the little C# guy a little bit over here. That represents the Microsoft tried to steal it, got sued, came out with C#. And then all the way over here to the right, you had the Apple things. So this kind of tells us our story. So this was Objective-C. 2 C's. Oh. Nailed it. All right. And then way down the line here, we had Swift. All right. And then over here on the left side, I probably had a bunch of different languages, and one of them over here was PHP. I'll just throw that in there for a second. And then we can throw Ruby in here. And we can throw Python in here. Then I probably, would I have Node.js probably? something like that. And then all through it, kind of had a little floaty guy out here for just JavaScript. And then somewhere in here, I probably talked about things like Ajax, jQuery, Angular, just going to leave it like that so you can actually read it. React, leave it at that for right now. All right, so how many of you have heard of at least some of these buzzwords? Ajax, jQuery, Angular, React. What have you heard about them, heard of them and related to? What are they all? What do those guys all relate to? Or web? Go ahead. They're webby stuff. Webby stuff. And really, it started with Ajax. We take this for granted now, but if the example I usually use is if you're on a web page that shows you updates for sports scores. The way it used to work is you had to keep hitting refresh to see the score, the new score, the new score, the new score. Now, that little part of the page where the score is, that'll update on its own, right? That's Ajax. Well, what's jQuery? jQuery is that, but better. What is Angular? It's that, but better. What is React? It's that, but better. All four of these technologies at the core do the same thing. They're upgrades to each other, but every one of them is a JavaScript library. None of these are their own language. All of these are just libraries written in JavaScript. So one of the things we run into in technology was we have all these buzzwords just float around. They all mean the same stuff. They all mean very related stuff. And it's so easy for us to get intimidated by the number of buzzwords that are floating all over the place. Right? So that's why I really want to emphasize this idea of learning programming as a skill set so that 3 weeks after you graduate, when you get a job someplace and they're using some technology that came out 15 minutes ago, you're able to adapt and go and learn that technology because that technology still is going to have a facility for creating variables, asking questions, and repetition. Make sense? All right. Now, what I was alluding to a second ago, or 4 minutes ago, whatever it was, is this language of PHP. So this was, let's call it our first language specifically designed for web stuff. To drive my point home here, it still had the ability to create variables. It still had the ability to ask questions. It still had the ability to create loops. But then it had a whole bunch of stuff built into it for doing web type things. Things that are commonly done when you talk about backends for websites. To make your life easier so you didn't have to write all that stuff from scratch. It just had libraries already written so you could just use it. Want to write something to a MySQL database? PHP made it easy. No problem. Otherwise, you had to create your own little ODBC connection, or with Java, it was a JDBC connection, and there was some setup involved, and it wasn't that friendly. But at the end of the day, you were doing the same thing. Just PHP made it trivial. Got it? So when new languages come out, they're usually designed with a specific purpose in mind, even though they might be classified as general purpose languages. C, C++, Java, C#, Objective-C, Swift. These are all general purpose languages that can solve all sorts of different kinds of problems. But realistically, if you're programming in Swift, you're probably writing iOS applications. Maybe you're writing a Mac application. But the Mac App Store is far less popular than the iPhone App Store. Okay, so you're probably writing iPhone stuff. If you're programming in C#, you're probably writing stuff for Windows. Okay, either or you're probably writing .NET stuff, either .NET based websites or Windows applications, or C#. C# has been adopted as the scripting language for, like, in the game programming class Unity. If you're writing Java, you're likely writing something for Android, since Android's such a big thing here, or you're writing business applications, probably not writing video games. If you're writing C++ today, you're probably writing something related to video games, probably in like a big company that has a lot of money, because you're, AAA type games where you're tweaking a lot of stuff at the low level code thing. And if you're writing something in C today, you're probably writing something for an embedded system. We don't necessarily think about these things as computers, but like your dishwasher at home has a little computer in it. Anymore, your toasters have little computers in them now. Your, Internet of Things toaster. You can upload like what you want, what image you want it to print on your toast. You seen these? Yeah. I mean, it started off as like you just had like the Yoda toaster, right? Where it would burn Yoda into your toast. But now you can just burn whatever you want into your toast. We've really come a long way. I don't know how we live without that, to be honest. I mean, I don't really like toast for peanut butter and jelly, but now I just use the peanut butter and jelly. Well, I use the toaster to put pictures on my peanut butter and jelly sandwiches. Yeah.
Is there any classes you're based with .NET?
Yeah, 370. Yeah, the software engineering class, you'll use the Visual Studio .NET stuff in there. But again, really pull the emphasis away from the language. If you're doing .NET, you're using Visual Studio, which is the same thing as the tool we're going to use in here called Eclipse, which is very similar to the other tool we're going to use in here called Android Studio. It just happens to throw in the, hey, I like to build Android interfaces piece into it, which is the same tool as if you're writing iPhone apps, you'll use Xcode. These are all just IDEs, integrated development environments, to make it easy for you to work with that language/technology. They're all the same thing. You might like one better than another one just because of how it's laid out, or where buttons are, or some specific feature that you just think makes your life a little bit more convenient, but they're all trying to solve the same problem. Write code and screw up the least amount of times. Got it? Okay. So in here, we're going to be using a tool, and I actually don't think I have it installed on this machine because I usually use my Mac to teach this class, so we'll go ahead and get it. So we're going to go to eclipse.org, and I have a link to this on the no, that's just the name of the current. That's just the name of the current one. Let's see. I need to. Those links wouldn't have worked unless I selected them to download in a new window. Is this it? Yeah. So you'll come here to Eclipse. If you have an older version, it's probably fine, but just since all of you are going to likely be downloading the latest, greatest, whatever, I'm going to go ahead and click download. Now, what I'm actually going to do, I'm not going to click download yet. You can download the Eclipse installer and then choose your features from there. What I'm going to do is I'm going to go to, there should be a way for me to get it just for Java developers initially. Under projects. Well, let me use my link I gave you here because I think I found it right from here. Yeah, this guy. So.
Do you need regular or IWE?
You want this one right here that I gave you a link for. Eclipse IDE for Java developers. That exact one. So if you use the link from Blackboard to get you here, then just download the one for your system. I'm on Windows, so I'm going to use the Windows 64-bit. So if you're on any sort of recent version of Windows, get the 64-bit. If you are running an older machine, get the 32-bit. You'll never be wrong getting the 32-bit. Life will go on. All right, so I'll go ahead and get the Windows 64-bit. I'm going to download this from Canada, apparently. And I'll put this in my downloads folder. I will allow cookies.
And donate $100.
Oh, did I? Did I donate? Oh, no, I could have. Should we donate? It's open source community. They're doing it for free anyways. It's the American way. Yeah.
Does the lab that right behind us have that?
The Mac Lab over there, or this one?
The Mac lab.
It has Eclipse on it. It might be one version older, but it's fine. It'll look the same.
Does every computer have it?
I think so. All right, so we'll get Eclipse here. Now, actually, if you're on a Mac, Eclipse usually installs more easily. I'll have to see what this current version, whether it comes with Java or we have to get Java here. But so I'll go ahead and open up this folder. So it just gives you a folder here called Eclipse. I'll extract that. Extract all. I'll keep it in my, well, I don't think I want it in my downloads folder.
And music.
Put it in music. I'll just put it on the D drive. So put it wherever you want it.
Music.
That's fine. You can put it in music. Oh man, look at the speed.
We're cruising.
It's just cripplingly slow at 0 bytes per second. I actually have this machine set up to mimic the current internet speed on campus. Isn't that weird that it's taken that long to unzip a file?
Yeah.
Do you mind it running?
No? Fair question. it's a fair question. All right, well, I'll let that guy cook in the background.
You need a new computer.
Should be a pretty good computer. It says a GTX 1070 in it.
2080. Get a 2080.
I know they're not making laptops with that yet.
You can get the one where it has two 1080 Ti's in it and a curved IPS screen for $9,000.
Is that a laptop or a desktop?
It's a laptop, but it's like a brick. It's like
So they went to Home Depot, got a big Tupperware container, just started shoving parts in it, and just put a laptop with the base on it. Gave you shoulder straps. All right, here. While this is cooking, let's go back into here. I'll go ahead and. Okay. So let's talk about variables in Java. All right. So actually, before we get to variables, let's talk about types. Now, remember all those slides from last semester? Like there are 3 different kinds of programming languages. There's 2 different kinds of programming languages, all of those guys. And one of them was that there are 2 kinds of programming languages. We have interpreted languages and we have compiled languages. Another one was, and I'll go ahead and let's just write those 2 slides real quick. 2 kinds of programming languages. So we have interpreted and we have compiled. Now, what's the difference? What's a compiler? We talked about it last semester. We didn't use one last semester. What's a compiler? Don't all scream at once.
Isn't the compiler it changes high level code to low level code before runtime, and then the interpreted is on same thing.
Yeah, so 3 kinds of programming languages. So we have low level. Well, we have machine language. We have low level. We have high level. What's machine language?
0 and 1.
Zeros and ones. What's low level? We looked at an example last semester of like hello world in assembly language.
Yeah.
This guy is a one-to-one relationship with the CPU. What does that mean? What does a one-to-one relationship with the CPU mean? Go ahead.
Is that like the infrastructure instruction set? Is that what it is?
Yeah, well, that's what I mean by the CPU side of things. What's the nature of our CPU? What does the CPU do? You know, our default answer is always, well, it's the brain of the computer.
The process everything.
Processes everything. And what does all that mean? So the CPU is this big, long list, this big instruction set, as you said, a big, long list of, I like to think of it as magic tricks. Here's all these things that CPU knows how to do. And each one of those things is pretty granular. It doesn't do a whole lot of stuff. Okay. And I think the example I often use in class, like none of you are impressed that I could like do that with my thumb. Okay. But that's a really important part of doing a whole lot of other things, right? If my thumb didn't move that way, then there's a whole lot of like moves, okay, programs that I can do that I wouldn't be able to accomplish because I don't have that one thing. Okay, so that would be like one of the magic tricks on the CPU. This would be like another magic trick. You know, this might be another one. So now you put all these little magic tricks together, and all of a sudden I can pick up this. That's a program that just did something. I accomplished an actual task, putting a whole bunch of these little magic tricks that a human being is capable of doing together in a certain order to accomplish that, right? I mean, if I squeezed my hand together first and then went to pick this up, I'd have trouble. So order of operation was important, right? Okay, so I had to reach there, squeeze, probably using several different magic tricks there. Okay, the CPU provides us all of those little tiny magic tricks. Okay, so when we say that a low-level language has a one-to-one relationship with the CPU, what we're saying is when we program using a language like that, we have to tell the CPU each individual little magic trick we want it to do. It would be like you giving me granular instructions on how to pick up this drink. You know, extend this arm. That probably even there's 50 magic tricks in there, right? You know, I'm using tendons and muscles and things like that. So imagine you had to tell me all of that at like the tiny per movement basis. That would be annoying, right? Okay, instead of just grab it. That's high level languages, just grab it. Okay, that's the high level language. So that's a one-to-many relationship with the CPU. Okay, that doesn't mean low-level languages are useless. It just means that they are extremely specific, extremely granular. Okay, and on this slide, we talked about this thing of a compiled language, which uses a compiler. Okay, and what does a compiler do? A compiler is one of our best friends. This guy, as was pointed out, converts between a high-level language and a low-level language. All right, so that means that you can tell me to just grab this drink, and then you run that through a compiler, which will break it down into the 4,000 little steps that is required for me to just grab the drink. Does that make sense? That way, we don't have to explain the little individual little steps that we have to take, all the little magic tricks in the certain order.
How many muscles it needs to contract.
Yeah, all the little things. All right. So compilers are quite sophisticated, right? Now, first of all, a CPU is far, far, far less complex than a human being. Okay. So even though as technology majors, we kind of view computers as being this really difficult thing and stuff like that. We kind of forget about how amazing we are ourselves, right? But it's because we're used to it. But the example I always use the first day of class in 200 is, how many of you got to class today without bumping into any walls and stuff like that? Half of us are reading our cell phones and stuff, or still sleeping. Don't dolphins do that? Don't they sleep with half their brain or something?
Yeah. I have no idea.
Yeah, I think that's a thing. Pretty sure.
Like half their brain shuts off.
Yeah, I think they sleep with their eye open, but they're up all the time, at least half up.
Okay.
Seems very efficient.
Isn't that burn them out though?
Well, the half of them are still sleeping. They're refueling. Yeah, they're good. All right, so compiler does that conversion for us because as humans, we want to work in this world right here, this high-level world. All right? If we can help it, that's where we want to live. We can tolerate the low-level world for short bursts. We do not want the 2-button keyboard. Any of you taken 325 this semester? Computer organization? I think you might have it. Yeah, you're taking it this semester? Yeah, we're going to be doing a lot at this level in there. Yeah, it's going to be great. It's going to be great. Yeah, usually you would take it as either a junior or a senior, depending on when it is on the rotation. So, yeah, in any case, because we only offer it every 2 years. So the next time you'll have it is when you're a senior, which is fine. Okay, so we kind of get the point here. We have different kinds of programming languages. Computer ultimately speaks machine language. We're going to operate on the far level away from that at the high level language, and then we're going to use tools in between to get us down to the computer language so that we don't have to talk to this guy on a 0 and 1 basis. Okay, so we particularly like high level languages. Some high level languages are interpreted, some high level languages are compiled. Compiled languages use a compiler to convert between our high level language and that low level language. And you mentioned that it does this prior. Creates executable prior to runtime using a compiler. Where an interpreted language interprets code on the fly during runtime. Now, based on those two statements, what are the implications of using those different kinds of languages? Interpreted versus compiled. Good.
Interpreted would be fast, but it might not be as accurate as compiled.
Why do you think it'd be faster?
Well, because with interpreted on the runtime, you don't have to have you don't have to set some aside the previous time.
Okay. I see the argument you're making. Yeah. So when you're working with interpreted languages, if you're not actually worried about execution speed, compiled language will execute quicker because you already have it down at the machine level, ready to go on the CPU. But with an interpreted language, you can just write some code and hit play, and it will just run. You don't have to set aside that additional time. It'll run slower than a compiled language will because it has to do that conversion in real time. Okay, the example I would often use is like if somebody's reading a speech and somebody else is listening to that speech and converting it to a different language. There's a little delay, right? That's an interpreted. That interpreter is interpreting the English speech and converting it into Chinese or something, right? So that there's a delay. Whereas the compiled version of that is the interpreter would get a copy of the speech prior to its delivery. He would convert it over to Chinese, and then at the same time, the news anchor or whatever could be reading the Chinese version of it while the American station might be given the English version of it at the exact same time because it was pre-compiled. It was pre-interpreted. Make sense? So interpreted languages execute more slowly because there's that delay, but the overhead is less, as he pointed out, where you don't have to go and do some extra stuff beforehand. which is actually a pretty good point that we don't necessarily see as programmers today. Because in programmers today, like when we use Eclipse here, we're just going to write some code and hit play, and it's just going to run, which to us is going to feel like even less work than last semester when we had to type in Python 3 space the name of the thing, because all that stuff is built into the IDE that is Eclipse. Even though when I hit play, it's compiling the program and then executing the program. It's doing all those steps behind the scenes so I don't have to. Right, so it's really doing quite a bit for me. All right. Now, we also talked about there are two kinds of programming languages. We have loosely typed and we have strongly typed. What does that mean? What does it mean? What's a loosely typed language?
Like Python, where you don't have to have the double splitter.
Okay, so it has to do with from the first place where a programmer would notice is when we're creating a variable. So when we're creating a variable in a loosely typed language, we do not have to specify what kind of value that variable is built to hold. Whereas in a strongly typed language, we do have to specify what kind of value that variable is built to hold. Loosely typed languages tend to be interpreted languages. Strongly typed languages tend to be compiled languages. Slower, faster, relatively speaking. The reality is our computers are pretty fast today, so we probably would not notice the runtime difference between a compiled and an interpreted program that did the same thing unless we were doing some real number crunching, like a lot of work. All right, that makes sense? So from our past experience, Python was one of these guys, a loosely typed language. Where in here, Java is a strongly typed language. So when we define variables in Java, we're going to have to say, this is what kind of value this variable was built to hold. Okay? What do we mean by types? Well, we have, this is the kinds of values a variable can hold. And that's actually probably not the greatest definition because you technically don't need a variable to have a type. You know, you can have a string without actually storing it inside of a variable, for example. But for us right now, we're thinking about things in terms of variables. If I have this little bucket I've created here to remember something, remember that's what variables are for, it's for us to use our memory. So I'm going to have this little bucket. I'm going to name this bucket something. So it's, it'll occur to me in 10 minutes when I go to use this variable, what it's holding. The name probably is going to be meaningful to me. In Java, we have to say, not only is this bucket's name my age, it specifically is built for holding an integer. I have to specify both of those things. What's the name of the variable and what kind of value belongs in there? Okay, where in a loosely typed language like Python, I only have to specify the name. I could have a variable called my age, and I would likely put an integer in there, just given the name of it. That would make sense, right? You probably wouldn't say my age and then put like a first name like Mike. In Python, you could, but that's be a kind of a misleading type of variable name, right? Okay, so we have two different types. There are two different types of types. LOL. two different types of types. We have primitive types, and we have object types. Now, remember from last semester, we talked about there are two different kinds of programming languages. We have procedural languages, and we have object-oriented languages, right? What's the difference between those two guys?
Object-oriented is like the phone that you have already,
Mhm.
and the other one is like the mess of wires.
Yep. So we had the example over here where I said, okay, well, if you walked into a room and you saw this giant pile of wires, and I told you that's a phone, that would be the procedural version of a phone, where you see all the details there, and it very well might be a phone, okay? But it's not what we visualize as being a phone. The object-oriented phone takes all those wires and just smushes them into a little container, right? Because most of those wires we never have to work with. And then it just punches little holes in there for the parts of that phone that we actually do need to interact with, right? All those wires are still there. We've just put it in a nice little box. So the difference between a procedural language and an object-oriented language is it gives us the ability to stuff wires inside of a box. If we're going to dumb it down to that, that's the difference. Okay? So it's actually a pretty simple jump. Remember, the job of a programming language in general is to allow human beings to solve problems in a similar way to how we already solve problems. All right, and when we think about making a phone call, or in today's world, texting somebody, but if we're going to make a phone call, we don't visualize the phone we're looking for as a pile of wires. We visualize something like this. This is a phone object that has a bunch of scary stuff inside of it, but I don't need to worry about that. I only have a button here, two buttons here, and one other, my Bixby button here that nobody uses. Anybody have a Samsung Galaxy that actually uses Bixby? You're trying to use Bixby?
Hard.
Yeah, I use Bixby sometimes by accident. I accidentally hit the button or I swipe an extra time. Yeah. Wish they would just get rid of them. This is the Note 9. This is the new one. And Bixby pops up more often on this. It's upsetting.
Can't you turn the Bixby on the home screen off?
Yeah, I think you can.
Yeah.
Too busy watching YouTube cat videos. All right, so we have two different types in our programming languages. This is true in Python. This is true in Java. We're going to be more aware of it in Java. We did objects in Python, right? Python was an object-oriented language, but for a long time in Python, we were using it as a procedural language. Right, we didn't start writing objects till like the last month of class. So even though we were utilizing a language that allowed us to write objects and use objects, we weren't really doing much with them. We were just kind of writing procedural stuff, showing all our wires, that kind of stuff. Okay, the same thing is going to be true for a little bit with Java, just as we're kind of making that little conversion jump. Like, here's the Python version, here's the Java version of the same thing, but we're not going to spend that long on it because we already have a baseline programming competency, right? So we're going to make that conversion relatively quickly, and then we'll get into the how do objects work in Java, comparing them to how objects work in Python, and you're going to see that there's a lot of similarities. Syntax might be a little bit different, but not as different as you think. And then all of a sudden, you'll be able to claim you know two languages. Okay? So, primitive types versus object types. What time are we done at 11:20 or 11:30?
20.
Okay. So,
1 more minute.
okay. Yeah, I got 1 more minute. 1 more minute, I can do tons. Okay, so primitive types. Primitive types built into C, C++, Java, C#, and Swift are byte, short, int, long, float. I'm going to do char next. Char, float, double, and Boolean. Okay, so those are the primitive types. I'm going to give some meaning to these. We've seen this slide before, but I'm refreshing this slide for us. I'm going to give some meaning to these next class. So for next class, go ahead and get your book or get your study groups kind of figured out. I'll say there is a risk of a quiz dealing with some of the slides we've dealt with so far today. I'll make sure I get them up on Blackboard. I don't know if it's a high risk, but a risk. 20% chance I might give a quiz next class. So be prepared. All right, questions, comments, concerns, bribes. All right, I will see everybody on Thursday. You guys are going to hang out for a minute?
Yeah.
Sure. So you know you can listen to that on Eclipse. Like download it and you're being similar.
He's recording me saying I made the
What does it say?
thread.
Fail to find.
I tried downloading it twice to get the same.
I'm guessing it's Java version. Try updating the Java version on your laptop.
Alright,
Just go to-
I had to go through like iOS and like I updated it. It's just the same.
Yeah. Because when the internal Java version is like 1.6 something. Go to java.sun.com or it's like oracle.com/Java, whatever it is, and get Java 1.8 or 1.9, the newest one, and see if it makes a difference.
Alright, I'll try that.
You won't need it for a couple classes, so we're okay for right now.
What class did you say that's outside of 2 years?
The one that's offered every 2 years is CSC250.
Do you know if that class is full?
No, I teach it. It's not full. So that's today at 1:10. So if you're going to graduate less than 2 years, get enrolled. So
I will be sending an email later for you telling you this, but I won't be in class Wednesday, Thursday,
I didn't say no.
okay, that's fine.
So,
You just watch the videos.
gotcha.
Awesome, thank you so much.
I've been meaning to ask you before, but do you think that the 325 is something that like I can do with only 200 experience, or do you think I should look about it doing it later?
I would say you probably can. I mean, do you feel like you're catching on to the programming stuff reasonably well?
I think I'm doing all right, but I don't know. I was just wondering what your thoughts are.
I mean, in many ways, I think it could be a benefit taking it earlier, because if you're catching on okay to this stuff, learning the assembly language stuff at the same time kind of shows you what's under the hood. I think it could be a benefit.
Gotcha.
I mean, would you take another class in its place?
I'm not too sure. Probably not.
Then maybe stay in it, and if you start feeling overwhelmed, then drop it. But
Yeah.
I think you'll be okay.
Okay.
That would be my gut feeling, is you'd be fine.